find the inverse of n under the operation star, the inverse of n. So permit me to wipe. I can wipe. Okay, let me wipe the first part. This is A. We just finished A. Now B. B. The inverse. I can still say let n prime, an element of R, be the inverse of the element n, which is equally an element of R. That means n is a real number, and so its inverse should also be a real number for such operation to exist, to be true. Okay, so if that's the case, then just know that the identity element results from you merging, or should I say, bringing the inverse and the element together. So if you bring this element and its inverse under the operation, it should result to the identity element, and it should be commutative, such that inverse first and the original element could still be placed interchangeably. You could switch their positions and it should still give you the identity element. Okay, so this is what we'll be running with. Now remember, the identity element was found out to be what? -2, right? Good. And so if that's the case, then let's go back to the operation. N star n prime is equal to, with the operation, n takes the first part, so you have n plus n prime plus 2 should be equal to -2. So I simply replaced m with n, and I replaced n with n prime. And remember I said it's commutative. If we're taking this part, this one, it will still give us the same thing. So let's uphold this part and solve. You're going to see that n prime is going to be -2 minus 2 minus n. -2 minus 2 is -4 minus n. That is the inverse of n. The inverse of n has been gotten. Okay, if that's taken, is it okay? And let's move to the next question, number 2. Now number 2. Number 2 says solve the equation. Solve this equation. 2 cos 2 theta minus 5 cos theta is equals 3. Let's solve the equation. 2 cos 2 theta. And it says for theta between 0 and 360 degrees. Where theta lies between 0 and 360 degrees. Solve the equation. So to get this done, solution.